Hello guys, welcome to our YouTube channel. So today we are going through a chemistry multiple choice paper. So this one is in O level paper of the May-June 2023 session, paper 1-1. So in this discussion, I will show you how to manage your term wisely and also how to use the method of elimination to find the best answers, right? So don't rush whenever you are reading each option. So you need to read each option carefully and make your choices uh, more accurate, right? So the first question says, in a change of state at a constant temperature and pressure, energy is released as stronger forces of attraction form between the particles. And also the average distance between the particles changes very little. So we need to highlight these key points, right? So we are then required to find which change of state is being described. So we've got option A, which says from gas to liquid, and then option B, which says from liquid to gas, option C, liquid to solid, and then finally option D, which says from solid to liquid. So we need to understand these two statements, which says energy is released as stronger forces of attraction form between the particles. So when there are stronger forces between the particles, this simply means that the particles are very closer to each other. So this simply means that gaseous phase is being cancelled out. So wherever there is gas, we then eliminate that answer. So this one becomes false, and then this one becomes false. And then we are left with the other two, C and D. So the distance between the particles is very little, and then energy is being released. So meaning to say, when energy is being released, the stronger forces are being formed between the particles. So this occurs during freezing, right? So during freezing, uh, that's where energy is being released when stronger forces are being formed between the particles, right? So this is liquid to solid. Are we together? Liquid to solid. So option D says from solid to liquid. So here energy is being absorbed to separate the particles. So this one becomes false. And then we are left with option C. Are we together, guys? So you need to message me in our chat box so that we can communicate. So feel free to ask any question right wherever you feel like we are lost. So we now move on to question number 2. So question number 2 says X, Y, and Z are elements. So we are given these two statements again. X and Y are in the same period of the periodic table, and then Y and Z are in the same group. So same period, same same period, therefore means same number of shells, right? Same number of so same same group simply means that we've got same number of valence electrons. So same number of valence electrons, right? So we need to use our method of elimination, right, to come up with the correct answer. So X and Y are in the same period. So this means we have got same number of shells. So we go to X and Y, then eliminate where the number of shells are not equal. So here we've got two shells, then here two shells. This is the first shell, and then this one is the second shell, which is incomplete. This one is a duplet state, and then this one is a duplet state, and then this one, two shells, two shells, two shells, two shells, two, three. So this one becomes false, and then three, three, right? So we have eliminated option C. And then we now use the second option. We say it's the same X, Y, and Z are in the same group of the periodic table. So this simply means the valence electron in the element Y is equal to the valence electron in the element Z. So we then compare the valence electron, and then we use method of elimination. So here we've got 7, and then here we've got 4. So this one becomes false. And then here 7, then here 7, then here 7, and then here 4. So this one becomes false. Then we are left with option B. So B becomes our answer. So we now move on to the next question, which says the number of electrons, protons, and neutrons in 4 different particles are shown. So here we've got this table, right, with the number of particles, the electron, the proton, and then the neutron, these subatomic particles, right? So they are then required to find which particles are isotopes. So we need to underline this term, of the same element. So isotopes, these are atoms of the same element, with the same number of protons, with the same number of electrons, but different number of neutrons. So isotopes, you need to know the definition, right? So you need to familiarize yourself with definitions of isotopes and then allotropes. So if you are aware of the definition of allotropes, you need to write your definition in our comment section, right? So isotopes, they've got the same same number of electrons, same same number of protons, but different number of neutrons, right? So we now go to our table and then compare same number of electrons. So here in particle 1, we've got 19 electrons, and then on particle 2, 18 electrons. So this one differs from the particle 1. So meaning to say they are not isotopes. And then option 3, 20. So they are not isotopes. And then option 4, 19, 19. So we now compare protons. We've got same number of protons, 19 here and then 19 here. So this one cancels out. They are not isotopes of any other option, right? And then neutrons. So our neutrons are different. So here we've got 20 and then here we've got 22. So option particle 1 and particle 4 are the only isotopes. So we then go straight to our answer, which is C. So C becomes the correct answer. So we now move on to number 4. So the question says some statements about the bonding in magnesium chloride are listed. So whenever you are reading the question, you need to start thinking about some alarming concept behind the compound in question, right? So magnesium chloride is an ionic compound which is formed by the transfer of electrons from magnesium to the chlorine to the chlorine atom, right? So we've got the formula, the chemical formula, magnesium chloride. So this one is the chemical formula. 2 electrons are being transferred from the magnesium atom to the chlorine atom to form the chloride ion, which is singly negatively charged, right? And then magnesium becomes a cation with the charge +2, and then chlorine becomes an anion with a single negative charge, right? So we then read our statements. So this first statement says each magnesium atom donates 2 electrons, and then each chlorine atom accepts 1 electron. So this one is correct. So magnesium here, and then chlorine forms this chloride ion with a single negative charge, meaning to say it receives a single electron from magnesium, and then magnesium loses 2 electrons to achieve a stable noble gas electronic configuration. So we then move on to the second statement. Chlorine forms an ion of 2 minus. So this one is false. Chlorine forms an ion of 1 minus. So this one becomes false. Magnesium atom and chlorine atom share electrons. So this one becomes false. Magnesium chloride is formed by ionic bonding, where there is transfer of electrons from one atom to the other atom. The metal donates the electron in the bonding. Magnesium forms an ion of +2. So this one is correct. So which statements are correct? Option 1 and 4. So this makes B the correct answer. Are we together, guys? So we now move on to number 5. So number 5 says ethane and ammonia are covalent compounds. So for ethane, we have got this chemical formula, and then for ammonia, we've got this chemical formula. So the dot and cross diagrams of these compounds are shown below. So you need to understand the displayed formula and how to write the dot and cross diagrams of each and every element. Like we've got methane. You need also to know methane. water, and then carbon dioxide. I think these one are enough for your junior chemistry, right? So let us read our statements. So the first statement says a molecule of ethane contains twice as many hydrogen atoms as a molecule of ammonia. So we go straight to the displayed formula and then count the number of hydrogen. So for ammonia, 1, 2, 3. Then for ethane, 1, 2, 3, 4, 5, and 6. So this statement becomes true. And then in an reacted nitrogen atom has 5 outer electrons. So we go straight to the periodic table and then find the number of the valence number of nitrogen atoms. So nitrogen is in group 5, which simply means it has got 5 unbonded electrons in the outermost shell. So this one becomes true. And then the statement 3 says, uh, in a molecule of ethane, the bond between carbon atoms is formed by sharing 2 electrons to form each carbon atom from each carbon atom. So we go straight to the displayed formula. This one is the shared bond between the carbon atoms. So this one becomes true. So this is true. And then which one is correct? So all these statements are correct. So our answer becomes A. And then we now move on to question number 6. So question number 6 says, when a strip of copper is placed in aqueous silver nitrate, a displayed reaction takes place. So you need to know this one. Write what is the ionic equation for the reaction which takes place. So a displacement reaction is another type of a redox reaction where the more reactive atoms displaces the less reactive atom in their compounds to gain stability. So you need to understand the atomic principle behind reaction of atoms, right? So atoms react in order to attain stability of a noble gas configuration. So copper from the reactive series, as I've alluded before in our previous series, that atoms react to achieve stability. So the more reactive the atom is, the easy of the atom to attain stability. So from the reactive series, copper is highly reactive than silver. So copper will displace silver from its compound, right? So the question requires us to give the ionic equation. So from our answers, we then eliminate formulas which doesn't contain the ionic equation, right? So this one becomes false, right? So and then we are left with these three equations. So I'm going to show you the ionic equation. So copper plus silver nitrate, silver nitrate. This one is going to give us silver plus copper nitrate, copper 2 nitrate. Are we together? So this one is in solid, and then this one is in aqueous, and then this one is in solid, and then this one is in aqueous. So the nitrate ion is what we call a spectator ion. It doesn't take part in the chemical reaction, but it is involved. It is there present in the reaction chamber. So for our ionic equation, we don't include spectator ions. We then include those ions which are taking part in the reaction. So it's copper plus silver to give aqueous here, solid here, to give silver solid plus the copper 2 plus. So in aqueous state. So we then compare which equation best suits our answer. So we need to balance this equation. So this one is balanced stoichiometrically, but it is not balanced ionically. So here we've got a single charge, single positive charge, and then here we've got a plus 2. So we need to put a 2 here. So this one becomes plus 2, and then here plus 2. But then for silver, we've got 2 silver, 2 moles of silver here. So we're going to put a 2 here. So this one is balanced both stoichiometrically and electronically. So we need to maintain the principles of chemistry. So we then compare which equation best suits our answer. So here we've got 2 silver, false. This one becomes false because silver is in its reduced form, whereas in the question silver starts in its oxidized form. So this one becomes false. And then here we've got 2 silver and then chiche. So this one best describes our answer. So, and then for the option A, this is advanced level chemistry for transition elements. So copper is not stable in +1 charge. So copper readily form +2 charge. So this one becomes false. Why? Because copper isn't stable in its plus one state. So it's not stable. So copper readily form uh, copper +2. Are we together? So this makes B the correct option. So we are now moving on to number 7. So number 7 says 3 compounds are listed below. So we've got calcium carbonate. Let me write the formula for you. Calcium carbonate. So these are what we call polyvalent ions or radicals. They don't exist on their own, but they are there. So we've got carbonate ion, 2 minus, and we've got sulfate ion, 2 minus, and then we've got sulfite ion, 2 minus, and then nitrate, and then nitrite, hydroxide, and etc. So you need to familiarize yourself with those radicals because you need to write the correct formulas for you to understand. So we've got potassium sulfate. So here is our sulfate. So the correct formula, right? And then let me rub this one, uh, our carbonate here, our sulfate here. So if you are not aware of how to write correct formulas, I've done a video on that one, how to write correct formula. So I've got simplified version of this video for you. So let me show you here the trick. So we've got potassium with this single charge, and then sulfate with this -2 charge. So here the 2 goes here to this side, and then I don't know what's happening with my pen. So here the 2 goes to this side, and then here the 1. So it's +1. So here the 1 goes to this charge. So this one becomes 2SO4. Right? Are we together, guys? Let me show you for sodium sulfate. Right? So for sodium sulfate, sodium, and then sulfate here 2. So the 2 here goes to become the coefficient here, and then the 1 here goes to become the coefficient here. So the correct formula is SO, right? And then for calcium sulfate, calcium 2 plus, SO4 2 minus. So the 2 goes here, then the 2 goes here. So we've got 2, 2, so they cancels out, right? So it's calcium SO4. Are we together, guys? Let me write calcium nitrate. So calcium nitrate is calcium 2 plus, and then the nitrate ion minus. So the 1 goes here, then the 2 goes there. So it's calcium NO3 2, because 2 is affecting this whole polyvalent ion. So I want you to write the chemical formula of which ion? Yeah, give me the chemical formula of sodium phosphate in our comment section. So you need to write the chemical formula of sodium phosphate in the comment section. So for zinc nitrate, so zinc readily form zinc +2, so it's zinc, right? So this is the chemical formula. So the question says, which row shows the element present in the greatest percentage by mass in each compound? So we need to highlight the core of the question. So here we need to take note of this, the greatest percentage by mass. So we need to calculate the molecular mass of each of these compounds. So MR of calcium carbonate. So we simply add the relative atomic masses of calcium, carbon, and then of oxygen. Then here of potassium, sulfur, and then oxygen, and then here zinc, and then nitrogen, and then oxygen. So the work question requires you to be able to write the correct formula. So you're being examined whether you're able to write the correct chemical formulas, right? So that's where the work question lies. So we need to add the relative atomic masses. So that one of calcium is 40 plus 12 plus 16 multiplied by 3. So this one gives us 100. Are we together? And then for potassium sulfate is potassium 39 by 2 plus sulfur 32 plus oxygen 16 by 4. So this gives us 174. And then for zinc nitrate, it's zinc 65 plus so we've got two nitrogen atoms 14 by 2 plus, and then we've got six oxygen molecules. So this one gives us, so we go straight to our calculator. So this gives us 189. Are we together? So we want to calculate the element present in the greatest percentage by mass in calcium carbonate. So as I've alluded to before, that we use the method of elimination when dealing with multiple choice questions. So here I've got two elements in calcium carbonate. I've got calcium and oxygen. So we simply go for to calculate the percentage by mass of calcium in the calcium carbonate compound. So it's 40, the AR of calcium divided by 100, the molecular mass multiplied by 100 to give us 40%. Are we together? And then we go for oxygen. So oxygen in calcium carbonate is 16 by 3 to give us 48 over 100 multiplied by 100 to give us 48. So for calcium, oxygen is the element greatest in percentage by mass. So we eliminate option A and option B. So we are left with option C and D. So for potassium sulfate, we've got this potassium being the only option for C and D. So we don't calculate anything on that because we've got the same element. So we go straight to the zinc nitrate compound. So for zinc nitrate, we are being examined to calculate for zinc and oxygen. So for zinc, it's 65 divided uh, 65 divided by 189 multiplied by 100. So we go straight to our calculator. 65 divided by 189 multiplied by 100. So this one gives us 34%, 34.4, 34.4%. And then we go for oxygen. So for oxygen is 16 by 6 to give us 96 divided. So it's 96 over 189 by 100. So 96 divided by 189 multiplied by 100. So this one gives us 50.8%. So option D will then become our correct answer. Are we together, guys? So if you have any question or you have any query, don't hesitate to message us in our message box so that we can give you our attention. So we now move on to question number 8. So question 8 says two aqueous solutions, Q and R, have got the same concentration in moles per cubic decimeter. So we've got solution Q, which contains 4 grams of sodium hydroxide in 500 cubic centimeter solution. Which solution could be R, right? So we've got this information which says the concentration of Q and R is the same in these units. So we need to convert the concentration of solution Q to suit these units. So we've got mass and we've got volume. So N is equal to N is equal to mass over mR. So this is the key equation in chemistry. You need to know this equation by heart. So N is equal to mass 4 grams over mR of sodium hydroxide. So mR is equal to 23 plus 16, the mass of oxygen, plus 1 to give us 4 over 40. Are we together? So it's 4 divided by 40, which simply give us 0.1 moles. And then we want to calculate the concentration. So we got this equation N is equal to CV. So you need to know these two equations by heart because these are the chief equations in stoichiometry, right? So N is equal to CV. So our N is equal to 0.1, and then our V is equal to 0.5 cubic decimeter, and then which is equal to C, the concentration. So we go straight to our calculator, right? Go straight to our calculator. 0.1 divided by 0.5. So the answer is 0.2 moles per cubic decimeter. So this is the concentration of the solution Q. So we want to calculate. We've got these options, right? Option A, B, C, and D. So we want to calculate the concentration of each and every molecule and find which molecule you've got the same, which solution have got the same concentration to that of solution Q. So we start by the solution on option A, right? So it's N is equal to CV, and then C is equal to N over V. We make C the subject of the formula. I'm sure you are all aware of it from your general maths. So C is our concentration, and then N 0.2, which is equal to over 0.25. So 1 cubic decimeter is equal to 1000 cubic centimeters. You need to take note of these relationships, right? So it's 0.2 divided by 0.25. So this gives us 0.8 moles per cubic decimeters, which is false. This is not correct, right? This is not equal to this one. And then we go on to calculate for the option B. So it's 0.2 over 0.1, right? So 0.2 divided by 0. We go straight to our calculator. This gives us 2, which is not correct. It is not equal to 0.2. And then we go to option number C. We say 0.05 over 0.25. So 0.05 divided by 0.25. So this gives us 0.2. So this becomes our answer. Then we can also calculate for option D for the certainty of the question, right? So it's 0.1 over 1. This gives us 0.1. So this is false. This is false. And then we are left with option number C. So C becomes our correct answer. So we are now moving on to number 9. So question number 9 says, a sample of 2 hydrated compounds are weighed and then dehydrated by heating. So the anhydrous compounds are weighed and then the results are shown. So we've got 3.97 grams of hydrated iron 2 sulfate, which gives 2.17 grams of anhydrous iron 2 sulfate. And we also have 2.88 grams of calcium sulfate, of hydrated calcium sulfate, which gives 2.27 grams of anhydrous calcium sulfate. So from this question, I can simply say the value of x is equal to 7, and also the value of y is equal to 2. So to those who follow us, to those who are aware of our previous recordings, can also agree with me, right? Because I've posted many videos on this water of crystallization. So it's only a matter of knowing your stuff, right? So you need to familiarize yourself with those waters of crystallization number of moles. So to those, for the sake of others, we can simply work this out, and let me show you how best you can do it, right? So we have got 3.97 grams of um, hydrated iron 2 sulfate, which gives 2.17 grams of anhydrous after heating. So to find the mass of water, mass of water is equal to 3.97 minus 2.17. Are we together? So let me go to your calculator. 3.97 minus 2.17. So this is equal to 1.8 grams. So this is the mass of water. So to calculate the number of moles, we use our formula N is equal to mass over mR. So we divide by 18 the molecular mass of water. So it's 1 over 8 over 18 to give us 0.1. So this is the number of moles of water. Are we together? So to calculate the number of moles of iron 2 sulfate, we have got the mass, and then you have got the mR. So it's m, the number of moles, over 1.7 over 152. And then this gives us it's 2.17 divided by 1.52, and this gives us 0.014276315. And then these are the number of moles of iron 2. So we then use the method of proportion. So we then use the method of proportion to compare the coefficients, right? So from the laws of water of crystallization, it is the number of moles of water bonded to 1 mole of a salt, right? So it's 1 mole of iron 2 sulfate bonded to X moles of water under standard conditions. So here in this question, we've got, let me call this one A. This number of moles of anhydrous iron 2 sulfate are being represented by A. So A is equal to 0.1 moles of water. Are we together? So for the number, to calculate the value of X, we then say A is moles 1 over A multiplied by 0.1 using your simple proportion. So we then store this in our calculator as A. So it's 0.1 divided by alpha A to give us 7.00046. So this is approximately equal to 7. So here we go for option D. So let us do the same for calcium. Let us do the same for calcium to confirm the answer, right? So for calcium, we simply calculate the mass of water. So the mass of water is equal to 2.88 minus 2.27 to mass of water is equal to 0.61, and then N is equal to the number of moles divided by 18. So this is equal to 0.03388. So this one is a recurring decimal. And we also calculate the mass, the number of moles of calcium sulfate. So it's 2.27 divided by 136. So this N of calcium sulfate is equal to 0.016691176. So we can store this one is our A, right? Store A. So we then compare. So 1 mole is equal to Y. and then A is equal to 0.03388 and so on. So Y is equal to 1 over A multiplied by 0.03388. Are we together, guys? So it's 0.038888 divided by alpha A. So this gives us 2.2990. So this is approximately equal to 2. So this makes our answer correct. So if you haven't checked on our playlist, you need to go on our playlist to find our videos, right? So the next question says what is a mass equal to the mass of 1 mole of water molecule? What is a mass equal to the mass of 1 mole of water molecule? So this one requires us to know the stoichiometrical principles. So 1 mole of any substance according to the Avogadro's law, we need to understand the Avogadro's law, right? So we've got option A, which says 24 cubic decimeters of water. So this is false. Why? Because water in its gaseous state, that's when it has got the same number of moles as that one of a water molecule. So this is false. Why? Because the Avogadro constant applies only to gases under RTP, room temperature and pressure. So we go on to option B, 1 mole of steam. So 1 mole of steam contains the same mass of 1 mole of water. So this one is correct. We go on to option C, 1 molecule of water at RTP. 1 molecule of water at RTP. RTP only work out for gaseous phases, right? So this one becomes false. So the mass of water, 1 molecule of water, is negligible, right? So we only talk about volume when we are talking about RTP. And then we've got 2 moles of hydrogen molecule and 1 mole of water molecule. So we've got, this is the hydrogen molecule, and then we've got 2 moles of it, and then 1 mole of oxygen molecule. So we simply add. So here it's 2 by 2, 4. 2 by 2, which is equal to 4, and then 16 by 2, which is equal to 32, right? This one gives us 34. So this is not equal to the mass of 1 mole of water. So this becomes false. So our correct answer is equal to B. Are we together?